Today we're going to factor by grouping, and technically this is nothing new. You've already done this. Back when we were factoring trinomials, when the a value was bigger than 1, we multiplied a times c and did stuff, and then we broke it into 4 terms. Do you remember when we broke it into 4 terms and then split it down the middle and then factored the first group, factored the second group? We've already done this, so this isn't really new. We are going to be factoring by grouping, and often factoring by grouping, there's multiple steps, like you have to factor multiple times. The first thing that you always want to check is GCF. Do the terms have anything in common? When it's 4 terms, it's actually kind of easy to check for GCF, because if your first term has no numbers and your last term has no variables, they can't have anything in common. So z to the third plus 5z squared minus 4z minus 20, they have nothing in common. So step 2 is we are going to split into 2 groups. We split it right after the second term. So right after the second term, split this into 2 groups. Step 3, factor each group. We're basically factoring the GCF out of each group. So what do z to the third and 5z squared have in common? Z squared. And if you need to, you can actually write divided by z squared under each of these terms to give you a visual clue that you are dividing each of those terms by z squared. So they have z squared in common. You can either think of it as dividing, or z squared times what would give you z to the third? That would be z. Or think of it as dividing. 5z squared divided by z squared is positive 5. So after you factor the first group, you should have z squared times the quantity z plus 5. Okay, good so far? Now we factor the second group. Huge helpful hint, whatever symbol comes in front of the third term, drop that symbol down. What do negative 4z and negative 20 have in common? Negative 4. Negative 4z divided by negative 4 is z. Negative 20 divided by negative 4 is positive 5. Do you notice that the 2 green sets of parentheses are exactly the same? You want them to be exactly the same. The next step is to, I call it collapse. This is actually the distributive property fully written out. You need to collapse that down into the factored form. Z squared minus 4 times z plus 5. Probably shouldn't have written that in purple. A question I commonly get at this point is, where did the other z plus 5 go? Or do we need a square on the z plus 5 because there's 2 of them? There actually aren't 2 of them. If we were to take z squared minus 4 times z plus 5 and multiply it out, we would do z squared times both of these. That's what's written here. Then we would do negative 4 times both of these. That's what's written right up here. So this is just the distributive property fully written out. The first term times the second set of parentheses, and the second term minus the second set of parentheses. We collapse that distributive property down into z squared minus 4 times z plus 5. Okay, give me a thumbs up if you're good with that step. Okay, now, is this done? Is this fully factored? Probably not. That is correct. If you see x squared minus, you are probably not done. Or in this case, z squared minus. If you see z squared minus, you might have the difference of 2 squares. So your last step is to check for difference of 2 squares, DTS. The difference of 2 squares is when you have a perfect square minus a perfect square. So z squared is the perfect square of z, and 4 is the perfect square of 2, so that factors into z plus 2 times z minus 2, and then we still have the z plus 5. And that is your final answer. Difference of 2 squares. Ooh, I totally just covered up that next problem, didn't I? Oh. There we go. First of all, check for greatest common factor. Do these 4 terms have anything in common? First thing that you should check is the first term is just x to the third, no numbers. The last term is just 18, no letters, so they can't have anything in common. After the second term, split this into 2 groups. All right, let's factor the first group. What do x to the third and negative 2x squared have in common? X squared. And that will leave us with x minus 2. X to the third divided by x squared is x. Negative 2x squared divided by x squared is negative 2. In the second group, drop that symbol straight down. That will help you. What do negative 9x and 18 have in common? 9. And because we dropped that negative down, they actually have negative 9 in common. Negative 9x divided by negative 9 is positive x. By pulling that negative out, that's going to help us to make sure the parentheses match. 18 divided by negative 9 is negative 2. Notice that your parentheses match. You have x minus 2 and x minus 2. Collapse this. X squared minus 9 times x minus 2. Is that answer done? No, it is not fully factored because we still have x squared minus. X squared is the perfect square of x. 9 is the perfect square of 3. So that blue set of parentheses factors further into x plus 3, x minus 3, and we still have the x minus 2. And that is your fully factored form. Okay, now, does it matter which order your parentheses are written in? No. You can have x minus 3, x plus 3, x minus 2. You could have x minus 2 and then the x plus 3, x minus 3. It does not matter as long as one of them says x plus 3, one of them says x minus 3, and one of them says x minus 2. All right, try C on your own. These 4 terms do not have anything in common, so we are going to start by splitting after the second term. X to the third and 4x squared have x squared in common. When we factor out x squared, we will be left with x plus 4. Okay, this is kind of weird. What do negative x and negative 4 have in common? Negative 1. If it seems like they have nothing in common, they always have at least 1 in common. And if you drop that symbol down, it helps you to see that they have negative 1 in common. When you factor that out, negative x divided by negative 1 is x. Negative 4 divided by negative 1 is positive 4. So our factored form is x squared minus 1 times x plus 4. Is that answer done? Is that factored completely? This is actually kind of a difficult difference of 2 squares to notice because a lot of people forget that 1 is a perfect square. So x squared is the perfect square of x. 1 is the perfect square of itself, of 1. So this factors completely into x plus 1, x minus 1, and we still have the x plus 4 at the end. Okay, there's something a little bit weird. Well, there's 2 things that are kind of weird about example D. So let's do example D together if you haven't already done it on your own. Okay, 3y to the third and y squared have y squared in common. 3y to the third divided by y squared is y. What is y squared divided by y squared? 1. A lot of people forget to put this term in there. You cannot let a term disappear. So remember that you could re-multiply this out to get what you started with. Y squared times y is 3y to the third. Y squared times 1 is y squared. That 1 has to be there as a placeholder. The next set, we drop the plus down. What do 9y and 3 have in common? 3. 9y divided by 3 is... Oh yeah, I totally made a mistake, didn't I? There's a 3 in here. Sorry if I confused you guys. My bad. Okay, so in case you didn't catch that, in the first group, y squared times 3y is 3y to the third. And in the second group, 3y times 3y is 9y, and then we have a plus 1. So our factored form is y squared plus 3 times 3y plus 1. Is that answer completely factored? It doesn't appear to be because there's still y squared in one of the parentheses. But do we have a pattern called the sum of two squares? No, we have the sum of two cubes, but y squared is not cubed. And furthermore, 3 is not a perfect square. It's 3. So if you have y squared plus or x squared plus, you probably are done. If you have y squared minus, you are probably not done. So this one is actually done. Your assignment is on page 184, numbers 23 through 28.